All right, so I guess that's it. Let's get started. Let me share my screen again. Design for machining. If you recall, in the very first session, I told you that you may say that, well, I'm just going to do the design. I don't care about manufacturing because I'm going to ask other people to do the manufacturing for me. That's right. However, as a designer, at least you need to know how things are made, and you need to know some basic understanding of manufacturing processes. And when you design things, you need to design them that, let's say for machining, they are machinable, all right? And another thing that you need to consider is vibration. So two things. One is the geometry that you design. And another thing is the vibration. Because tools vibrate, and you need to consider how fast you can cut when you do a machine. So first, let's focus on the geometry quickly, and then I'll get to that fusion in a moment, all right? So let's say between these two parts that I'm machining, part A and part B, let's say in both scenario, I have a cylinder which I want to do this, let's say, pocket or a slot inside this. So between these two parts, if it's possible, I should have a flat surface at each side because it helped me to fix the part and clamp the part on the machine. So flat surface for clamping. So that's something that I need to consider in my design. Like the first one, part A, it's very, very difficult to clamp it. And I don't get an accurate clamping as well. So if the design that I do involves, let's say, a hole, then depends maybe on the geometry that we have, we may decide that, oh, maybe the diameter of 10, let's say 231 millimeters is what I need based on the design, optimization, stress, and other things that you did. But this is not good because there is no tool that can create that hole for you unless you order a customized tool, which is going to be super expensive. So you'd better always check the available tools. And there are standards, you can check them up and see if you may find like 10.625 millimeters, something that is available. And you go with that one, all right? I already told you, avoid narrow hole, narrow, long hole, because there is no drill bit that can stand drilling a long hole. Or this one is obvious, the overhang is bad. Overhang result in large deformation. So avoid that. If you have to, then you need to come up with a better solution to fix the part on the machine. And this one is important, the sharp radius, like this one. It's very difficult to machine those. If you use, let's say, you will see in milling, then you need to use a very tiny tool bit, like drilling tool bit or milling tool bit, which can create a lot of problem. So you'd better to use a reasonable radius. It also reduces the stress as well. Okay. This one I discussed with you in the very first session. Avoid thin wall, like this one. So this is bad. And this one, we talk about it. Long, narrow hole. Long, thin holes. That's bad. But something that I've seen a lot people do mistake is when you create, let's say you want to drill a part that, let's say, has a hole here. So of course you use a drill bit, something like that, let's say. So something that I've seen a lot that people don't consider is that, well, I need maybe a drill, sort of a tool holder, right? So we should consider the room for tool. So right now it's not possible to fit a tool holder there. No room for tool holder. All right, so these simple things you need to consider, and the radius, so that's also is critical to consider that. With this general concept, for example, in here, between these two parts, again, part A and B, it is obvious that you cannot make these two, right? This part over here and this part, you cannot machine them. Not possible to mill, to do milling, which you will see in a moment in that CNC that we are going to do. So instead, you'd better like use these radius at the corner, okay? So I let you guys to figure out for this example, which configuration is the best, but I'll also post a solution. We want to make a mold for a thermoforming, or a part, sorry, for a thermoforming, and we need to create a hole. Which of these configuration you go with? Give it some thought, and I'll post the solution for you guys as well. The second part, before we go to the actual creating the geometry for machining, is the vibration. So there is a phenomenon which is called chatter vibrations, or chatter phenomenon. What it is? So in simple word, it is the vibration of the tool during machining. But what type of vibration? If resonance happen, or resonance occurs, all right? So the key here is these resonance things. But what is resonance? I'm sure in one of your physics course, you've seen it, but just to quickly remind you, let's say if, let's say I have maybe a simple box on top of this one. Let's say I have spring, and then on top of this spring I have, let's say, maybe a mass m. All right, so this is mass m, and the stiffness here is k. So from physics, if you remember, we defined something which we call natural frequency, which is k over m. Stiffness divided by mass, the square root of it. And natural frequency, if you remember, we said omega n is equal to 2 pi fn. If I displace this m in 1 unit of second, how many full cycle it does, how many times it goes up, return back, goes down, and return back, right? We call it omega n natural frequency, or fn natural frequency. Now, if I start moving this base ups and down, all right, move ups and down. If I start moving it ups and down with, let's say, the same frequency, 2 pi divided by omega n. T is the period that I do a full cycle. So this T time for one complete cycle, right? So I move it up, return back to 0, move it down, and return back to 0. How long does it take? T. If this T is equal to 2 pi over omega n, what is omega n? Depends on K and M. Then the system is going to experience resonance. What will happen? So this mass M, the vibration is small, it becomes bigger, 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 and bigger. This is what we call resonance, all right? So it is critical for us because in many machining that we do, let's consider milling, for example. In milling process, let's say this is a milling tool. All right, this is our milling tool that is rotating with the rotation N. Of course, we have the cutting force, let's say F. This F results in a deflection. And I can say this one is equivalent to a stiffness of 3EI over L3, which L is the length of it. I hope you guys remember from MEC 2 or MEC 360 that if you have a cantilever beam, the deflection of a cantilever beam is FL3, 3EI. All right? So that's deflection of a cantilever beam. Stiffness. So what I'm trying to say here is, look at this tool, right? And apply load F. So treat this tool as a cantilever beam. How much does it deflect? From MEC 2 or MEC 260 or MEC 360, hopefully you remember that deflection of this beam is FL3 divided by 3EI. Am I right, Jesse? You approve?
Yeah.
You're right.
Or at least that sounds correct.
Okay. So hope you guys remember this formula. So if the deflection is like that, and we have a formula for, let's say we have a spring, F is equal to K delta, then we can approximate that the stiffness of a, basically, let's say a tool, a milling tool can be 3EI over L3. L is the length, E is modulo of elasticity. What is I? Who remembers I?
Moment of area, or second moment of area.
Exactly. Yeah. So let's say that's the cross section. That's the cross section of the tool. Then I has a formula pi over 63 d4, moment of inertia. All right. So what I'm trying to say here, for each tool that we pick, depends on its material, depends on its diameter, it has a stiffness. And we need to be careful when if we calculate its natural frequency, square root of K over M, then the rotation speed, we don't set a speed that be equal to be equal to omega n. All right. We'll do one calculation maybe in future, but for now, just keep it as a concept. I have like a video here shows in a turning process. Let me see if I can play it. But I put the link for you guys there. Yeah. So you guys can see it. So we start with the turning, the vibration becomes bigger and bigger and bigger. So for us in the turning process, instead of getting a round, nice cut, we ended up, as you saw in this video, with a, basically it's not a round base, right? Again, let's say that's the tool and the vibration. We ended up with not a round surface. All right, so, and we want to avoid that one. But now the question is, how can we avoid chatter? So this is what I wanted just to mention before we go to the CNC part. So to avoid chatter, there is something for each machine, luckily, which is called stability lobe diagram. But what is a stability lobe diagram? Like if you buy a new milling machine, maybe you're lucky in the brochure, it has that stability lobe, or there are ways to find this stability lobe. If you in CME, if you walk past the automation machining lab, there are many grad or PhD students. If you ask them what are you working on, they say we are doing our research on stability lobe diagram for different machining process. And there are like simple way to find this. So in this stability lobe, the x-axis is RPM and the y-axis is depth of cut. But our job is just to check these stability lobes. You don't need to create them. And these stability lobes looks like something, depends on the machine and the tool and everything that we have. It may looks like something like this graph, like that one. So what this graph is telling us is that below this graph, like over here, is the safe zone. So this is safe. So this green zone, we are safe here. But above this boundary, we get to the chatter zone. All right. So how it's going to help us? Let's say I'm doing a machining process and I'm experiencing chatter. I check my RPM and I check my depth of cut and I realize that, oh, I'm here. Okay. So how can I fix then chatter? So you tell me. We just need to move to the green zone, right? So I have two options. Either I can decrease the speed, decrease the RPM to move to the green zone, or if I have to keep the RPM, I can decrease the depth of cut. Simple fix. So that's why it's so critical. If again, please watch those videos that I posted. Chatter is a really critical phenomenon. It damages tools, it damages the surface, it's noisy. But with a simple fix, changing the depth of cut or changing the RPM, we can fix it, all right? So it's gonna then here, we are gonna have chatter. To fix it, we should either decrease RPM or decrease depth of cut. And ironically, sometimes by increasing the speed, we may fix the chatter. Let's say you are over here, right? And this is where it gets very interesting, and many people cannot figure out this one. But in industry, you just tell them to increase the speed, and the problem will go away. Problem will be solved.
Are stability lobe diagrams tool dependent? Since you mentioned earlier that it seems like the K is dependent on material or the tool properties. So
exactly, yeah. They are machine dependent and tool dependent. So why machine dependent? Because how rigid the machine is, how rigid the tool holder is, how strong the structure of the machine is important, and also tool dependent. That's why there are brochures and charts that tell you that if you go with a milling tool that its length is in this range and its diameter is in these things, or you're using carbide tool, then this is the lobe that you have. If you are using another tool with different diameter, this is your lobe. So you don't have just one fixed lobe for each machine. For each machine, there are several lobes which you find that one is right. And then simply by changing the RPM and depth of cut, you can solve the problem of chatter. Okay? And these things, again, many people think that, let's say you are in this second point, right? This point 2. And your machine is experiencing chatter. You are unhappy. You decrease the depth of cut. Still, the problem is there. You decrease the speed. Let's say you move yourself around here. You see the problem is still there. However, maybe increasing the feed speed, the RPM by just 50 RPM, the problem solved. Okay, that's why these stability lobes are important. All right, so now if we are good, let's switch to that fusion things. Is there any question, guys, so far? Are we good? All right. And also, I posted for you some videos, 2 videos, one as a pre-lecture activity, probably you've seen, and another video which exactly walk you through this stability lobe, like this 2 point that shows how you can, like this green point, this red point, which is chatter, you can move to a stable point, like either by increasing the RPM like this one or decreasing the feed speed. Let me save this file and bring up the fusion, okay? So you guys can see my screen? Are we good?
Yeah.
Good, all right.
Good.
Let's try it. I haven't tried with Zoom running these fusion things. Let's see and hope if it cooperates. All right, so Fusion 360, I'm not going to teach you the modeling. I posted 2 short videos. You can watch those videos if you haven't. It's a very powerful software. It's similar to SolidWorks, but its capability is way beyond SolidWorks. Also, if next year you're joining industry, then this software is more attractive to industry rather than SolidWorks. It has collaborative things, which like different team members can collaborate with each other. It has a stress analysis, dynamic analysis, mechanism, and the manufacturing part of it is really cool. So I strongly recommend you invest some on it, spend some time and learn it. It's a great thing to be on your CV, and it's super easy to learn. Okay, so let's say I want to do the project that I ask, and the project is very simple. Let's say I have a pocket, I have, sorry, a block, and I want to make, let's say, create a pocket in it, okay? So first I start with modeling something, okay? For modeling, so you see the tools that I have. First of all, I'm in the design mode. Over here, you see if I click on this one, it has design, it has generative design, rendering, animation, simulation, and manufacturing. We're going to work for now on the design and manufacturing part. So I'm on design mode. Okay. So in design mode, I have different, like on this menu, I have like create menu, this section. Like this purple one it's more like clay. You can form different shape, which later I will show you when you need to create the mask, the mold for the mask project 2 or 3, I believe. 2, I guess. But for now, we forget this purple one. The second part is modify when you create a fillet and so on. And then we have assembly and other tools, all right? So like similar to SolidWorks, we start with a sketch. I click on this icon at the beginning over here. If you can, hopefully you can see my cursor. So I can select a plane that I want to create a sketch on it. Let's say on this one. And let's move this video away, all right? So I create, let's say, a rectangle, anything that I want, all right? Something like that. I can go to dimension, or just I can click on D means dimension, and select the width and the height of this thing. Let's change it to 100. And this side, let's change it maybe to 75. Okay, so rectangle 75 by 100, very simple. Then I just over here, this green check mark here, it says finish sketching. It means I'm done with my sketching. Right top corner over here. So I click that one. Now, similar to SolidWorks, I say SolidWorks because you guys are familiar with SolidWorks, we do extrude. So this option over here on the create, you see this one is extrude. I click on extrude, says how much you want to extrude it. I move it up, or I just select a number. Let's say we say 15 millimeters. Okay, we create a box. Now let's say I want a pocket in this box. And to create a pocket, again, I create on a sketch, the one on the top, and I say this is the surface that I want to create a sketch. Let's say the pocket that I want to create is maybe something like that. Let's also have another pocket here, just for fun maybe. And maybe let's have also a triangle. We don't want triangle to be sad. We include that one there. All right. So again, I can click on D. I can change the diameter of this one. Let's say 20. I can change this length to be something standard. I can change this one. And the same for triangle, you can change the angle. For example, here, what do you want the angle to be? So this is not a nice angle. Let's change it to 110. You got the idea, right? And let's say the position of these things, you select the center, you select this edge, and this distance, you want it to set it to maybe 20. Something like that, all right? So you finish with your sketch for the pocket that you want. Again, you return back and you click on Finish Sketch. And now this time, again, we select on Extrude, the one on the top, and we select this area that we just created, all right? These three. If I move them up, it means I'm extruding them up, but I'm gonna create a pocket. So instead of having a positive number, or I can just push these things down, so you see it becomes red, or here I can just enter minus maybe 5 millimeters, all right? So that's the pocket that I created, 3 random shapes. Now it's time to do a milling for this one, but you guys think that we can machine this one down and create these pockets? It's okay to do that?
You need fillets.
Great, yeah. This sharp corner, we cannot really machine that and create those. Our tool is gonna say, sorry, I cannot do anything for you. So, as Jesse pointed out, we need fillet. Here we see on this modify option, if I click on fillet, I can create this corner. By the way, if I click on shift, if I hold shift and the middle, if you're using a mouse, like the middle key, then you can click on the rest rather than repeating the process. You just click on this and you select the fillet that you want, let's say 4 millimeters. You're happy with 4 millimeters and we'll leave it 4. Or any other numbers that you feel for your design. The same for this triangle, I select fillet. Again, I select those edges, like this edge, and the other edge over there, and maybe that one too. By the way, did I click on record or no? I hope I did.
It's recording.
Recording, okay, good. So, and 4 for this one, all right? So, we create the pocket that we want. It's smooth, it's okay. You can even change the radius for here, but that's fine. You will see we have tools to create this sharp corner at the bottom, right? Problem is this round corner around here. So this is the pocket that we have, and this is a part that we are happy to make. Now, we know to make this pocket, milling is the best process to go with. Right? Let's do that. So if I go to design, and then I go with, like, I select manufacture, okay? I go to a different environment. And by the way, nowadays with CNCs being available, nobody do this sort of work by hand or manually. Even in mech shop, unfortunately, because of COVID, now you cannot see it, but we bought 3 CNC machines. I have one, a small one in my lab. In future, if you guys want to use it, feel free. Okay. So what I'm trying to say, nowadays we just create a G code and do the automatic milling rather than doing it manually. So we are here, 2 simple steps to create a G code. How we do that? First step, always setup. Over here, you see the first tab that I have here, setup. I click on, I open this one, and I say it's a new setup. Okay, so setup is a very simple thing. Where do I want my coordinates to be? That's the setup. And also, I want to say if this part that I want to do the pocket, is it something that I need to do pre-process, like before doing the pocket, like removing and smoothing the surface, or no, the material, the length that I want has been set. So over here, you see there are 3 tabs on this menu that I have. The second one, the yellow one, which says stock. So this is where I decide if I want it to be 0. See, if I set it to 0, it tells me that the size that I have is the final size. I don't want to do any extra work, any machining on it. Okay? So that's the first step. The stock, you set all of these things 0, unless after doing this pocket, you want to do sanding and you want to smooth it and you want to sort of remove extra material. But for this example, let's keep it simple, nothing we want to do. The first one is very important. The first tab is where we basically set our XYZ. We need to select an XYZ, so when we put this box in our machine, we know where is the origin. So the tool, we need to tell the tool that this is, hey, this is the 0 point, okay? So it means that I need to select like sort of a point that later I can recognize where is the 0 point. So it's bad to have it at the center because we need to do measurement. It's very common to select this corner, at one of these corners as the origin, because we know where it is. So how we do that? See on this box that we have, it says, where do you want your origin? You see the word origin here? I open it up and I say, I like to select a point. And it asks me, okay, please tell me which point, and I just click one of these corners. Now this is my origin. Also, I need to tell my tool that what is X, what is Y. It's very, very common in milling process that the Z axis to be the milling direction, basically, all right? It can be different, but we have to tell machine that Z is different. So we need to select X, Y, so Z is like the vertical direction. How I can do that? Over here, the orientation, you see, I open it and I say, I want to tell them the program what is X, what is Y. So I just select X and Y and I say, okay, I want this one to be X and I want this one to be Y, but I like to flip Y. Now my Z axis is like in the vertical direction and up. This is more like a standard way of milling. However, it's okay if you select a different X, Y, Z, but later you are in trouble when you set up your machine. Is there any questions so far, guys? So all we did so far is just setting up X, Y, and Z at one corner of the box. Go ahead.
Just one quick question. Will it affect the orientation we place this in the machine?
Yeah, it affects. So if you are doing a milling machine, let's say, and you know that your milling tool is a vertical milling machine, then you always set the basically your z-axis to be aligned with the tool, basically. So always remember this z has to be the tool. Now it depends on the machine you have. If your tool is horizontal, you set it so your z-axis is the horizontal tool. Okay. As a general rule of thumb, z to be the tool, and when we set it, like the tool, when it creates this pocket, it's going down, right? So going down means negative, means removing material, stepping down. So that's why this z-axis maybe should go up, normal to the plane. Okay. Soon it will become clear why I selected this X, Y, Z. So far, is it clear, Ahmad? Are we good?
Yes, everything's good.
All right, so I just click OK. So this is what I have here. I did my setup. By setup, two things that I did. I don't have any extra material to be removed. And also, what is my coordinates? And I pick a corner because a corner is the best place. Later, when I place these things on the machine, I know because I move my tool and bring it to this point, and I click on the home basically key and say, this is the 0 point for the tool. Okay. What is the next step? I'll do the process. So here, you see over here, we have different process, turning, additive, which later I will teach you that one as well when we use for additive manufacturing. For now, we just want to do it's all on the category of turning, however, we call it milling, right? If I open it, for example, it says 2D additive cleaning, adaptive, cleaning. But what we want to do is this 2D pocket. Face, when we clean a surface, you just saw in previous lecture, face milling and create a slot, thread, different process which you can play with them later, creating a thread, creating a circle and different things. 2D pocket, very common. I click on 2D pocket. That's all I need to do. Click on 2D pocket. And a new window pops up here. You see this new window? Let me walk you through that. If you get this part, then we are done. First step first. What is my tool? You see here, it says tool. I click on select. All right. Now I need to select a tool. So luckily it simplified things for me. I don't need to go check all these tools because many of us, we don't know these codes or these things and it's confusing. However, we can Google them. But what we do on this right side, you see it says milling, hole making, turning, and so on. I just filter different tools. I select that I'm interested in milling, all right? So I clicked on milling, and then I see new things pops up. What type of milling that I want, right? You see here we have ball end milling. Ball end milling, it means the tool is round at the bottom, but we want a flat surface at the bottom. So I pick this flat end mill. See, flat end mill, all right? I can set up different things, filters different things, for example, this diameter, the range that I want, and so on. So you can play with it later. But based on this, I have the inch and the equivalent in millimeters. Let's work with these SI units. Maybe this tool is something that I'm more interested, 3 millimeters. So I pick this tool. Why I pick this tool? Because if you remember the corner that we had, the radius was 4 millimeters, right? So maybe this one is a better fit for us. Even though if I go with 5 millimeters, still I can get the job done, but the corner I don't get those radius that I want. Let's go with the 3 millimeters. And again, still you can modify things. You see for these tools that it shows, if I click on, for example, select, the tool has been selected. And now I have the tool over there. And this is just a schematic that I have here.
I got a question.
Go ahead.
Can we not go with the 4 millimeter milling tool?
We can go with the 4 millimeter tool. If we have that tool, all we need to do when we select that tool, right? You see here, and over here at the top, you see this pen. Can you see it?
Yeah.
So if I click on that one, it means I can edit my tool, all right? So what do I need to do? I changed in the diameter instead of 3 millimeters to 4 millimeters.
Well, there was one available.
Sorry, say again?
There was one available, so you wouldn't have to make.
Well, yeah, exactly. That's what I'm, yeah, you can pick one, or if there isn't any available and you, in your shop, you have a new tool, maybe the diameter is 2.5 millimeters, what I'm trying to say, you can still change things. So this is some let's say, some tools available in this library based on some common tools that people use. However, you have the option to change it. For example, you may go with a longer overall length or overhanging of this length. It depends on the function that you have. What I'm trying to say, you can modify all of these, all right? Is that clear? But you're right, we have the option to... Not drivable? Say it again, sorry?
I didn't say anything.
That might have been background noise.
Probably.
Okay, so let's select this tool and say we are happy, but later please play with it and select different tools and see what happens, okay? Then we need to decide for two things here. That's where the vibration and those stability low comes to play, okay? For this project that you do, I already told you what should be the speed and the feed speed and the RPM, but in practice, you decide for spindle speed, like the RPM, automatically, based on the material that you select for this, the program decides for your speed, but this one says 12,000 RPM, and then it calculates the feed and other things based on the tool, the depth, and other things that you have. But you may say that, no, I don't want that fast, 12,000, maybe I go with 3,000. It is 3,000 or 300? 3,000. And then you see automatically it calculates the rest for you. You may say that my feed rate, I don't want it to be that fast, all right? Instead of 12,000, I set it up to maybe 200. It's going to be very slow, but this is what we decide to do, okay? And the rest, we just leave it as this. Two numbers then, the spindle speed and the RPM, all right? We have the depth of cut, so we can look up the stability low in future, but for this practice, you can again play with these things. So we select the tool, we select the feed and so on, and then the geometry. Now we need to tell where we want to machine, right? So I click on the second tab here, it's geometry, right? Because still we didn't tell the program where we want to create the pocket. So I need to select the pockets. It says pocket selection. So to do the pocket selection, I just select the bottom of these pockets. So this is one, all right? I can hold the control to select the second one. So again, don't forget, hold the control to select the second pocket and then the third pocket. So this is, so the bottom of the pocket then, not the top, not the contours, right? Not these contours, this red one, no, the bottom. This is our pocket, basically. We are almost done. What are the rest? The rest, like this one, if I click, it just program calculate for me like the safe, basically distances for the tools. Based on the length of the tool that I have, it says that this red one is where your tool is gonna stay. This green one is where your tool is coming down and then start rotating. And this blue one is your 0 point where the machining starts, the first layer of machine, basically. Again, program adjust those for us, but depends on the machine that we have, or maybe we are scared that our tool is too close, we can adjust them. The more, like the important one is this 0 layer, this blue one, which sometimes people change that number. They want their first layer of machining just to be air, nothing else. Like they just want to see the tool path. Like the machine doesn't do anything for you, just cut air for you. Move about the surface so they can check that everything is okay. We can move these things ups and down, but the program does a nice job, select the numbers for us. And then this, what is the second tab? This one here, and you can see I'm just moving through these tabs. The first one was the tool. The second one was the geometry. This one is the high for the tool. And the second one, if I click on it, so by default, the program wants to do this milling for us in one shot. Like the mill goes down and do it in one shot, but it's not a good idea. We don't get a nice clean pocket. Rather, we should do a multiple depth. See here, this word here in the middle, multiple depth in this table. If I click on that one, so it opens up something for me, and it suggests that do you want me to like do it in 0.5 millimeter depth, all right? So, and then the last layer to be 0.2. I say, no, I don't care about the last layer. I set it to 0, and then maybe each of these to be like 0.5 millimeters. All right, so maybe it gives me an error. It doesn't like to be 0. Let's set it to 0.2. That's the basically last layer. Oh, this is a very small number, sorry. 0.5 millimeters. So you will see in a moment what do I mean by this number. So basically, now my tool is not going to do in one shot this milling for me. It's going to do layer by layer. Each layer removes 0.5 millimeters until it gets to the last layer. The last layer, instead of stepping 0.5 millimeters, it removes the smaller layers. But the program does the calculation for us, so it gets to that round number that we have. If you're all done by that, we just click on OK, and let's see what will happen. So this is what we'll get. Some of these blue lines, you guys can see. Yes or no?
Yeah.
All right.
Yep.
So this is this blue one. These are the basically the tool path. Let's run a simulation. So, and the good things about this software is before going to the machine, you can see what really happens in practice by just doing a simulation. You see over here the action in the middle here. If I open that action, then I have an option for simulation. You see that simulation? I click on simulation. Now I'll see these things. It just shows me the tool, but I can turn on also the, you see here on this table, tool. It's just for the sake of visualization. You just want to show the shaft or the holder as well. You click on the holder, so it shows the holder for you. It's always good to show the holders because then you can basically see if the holder is gonna hit any points or a clash is gonna happen, all right? So do you want to show the tool path and so on? This is again just for the visualization. You can select different colors and so on. If you are done with your visualization, you're happy with that, you see at the bottom, this play button, let's click on it and see what happens. I click on it. So it shows how these things is gonna be cut. So the tool path, in fact, shows me the tool path. So the red one, it's when the tool is going in, all right? And then the blue is basically the actual tool path. So that was the first layer. And now the second layer, all right? So why not let's say if I turn off this tool path, you see, it just shows the motion. So, but it better show the tool path. You can select different material here. This is good for you to make sure that the pocket you're creating is right and correct. If I turn off the tool path, you see the pocket has been created. You guys can see it. Yeah. So hope it's not slow on your side, because I know sometimes with this Zoom, it can be slow, right? So this holder, I can, again, I turn off just show the shaft so you see where the tool goes. I can click on the tool path, so you see the tool path. Again, this is just for the sake of visualization. The actual part, we have done it. This is just, we want to make sure that we are not creating, like our tool is not gonna move somewhere crazy and create something crazy, all right? So let's be patient and see what will happen after it finished with the first pocket. And you can change the speed for this visualization, but this is like the real time based on the feed we selected, the diameter, of the tool, like the geometry. It shows the actual time. How long does it take to do the actual machining for this process? Somewhere you can select like faster or slower, but I don't do that because it's going to crash. So see, the yellow one is when it switched from the first pocket to the second pocket. Ahmad, you are still there? You can see the yellow line?
Yep, can see it.
All right, good. So to show it more actual one, I can turn off this tool path. So it is nice, right?
Can we actually control the number of passes? Because this is a very small cut, so for a small cut, will we need actually, because I think it went around for like 7-8 times.
Yeah, so you remember that the depth of cut, the multi-path that I selected? Yeah, you can control it. What I selected 0.5 millimeters. It means in each layer, it basically removes 0.5 millimeters. As you can see, it's a lot of layer. But yeah, of course, you can change those as well.
0.5 millimeters seems really small.
Very small, I agree.
A bit excessive.
Yeah, so I agree, but I wanted just to show you guys and also test your patience. So you guys are happy with that so far? You understand the process?
Yeah.
Good. So this is how you check what will happen in the actual machine. Again, this part is just for the visualization. You can turn it on and off each part. Even you can show the flute. You can show the holder. You can change the material. This is just for, again, visualization. It doesn't mean changing the actual material in the actual process. I can go for this plastic, just the appearance is apparently similar to this, or I can go for the metal, and so on. We play with those things. Now that we are happy with the toolpath, we are happy with everything, we need to give the machine something, we call it a G-code. That part is very, very simple. Over here, you see the action where we did the simulation. If I open it, now I have an option for post-process. All right, we did the simulation, right? We go to post-process. You guys all hope you see it. I click on post-process. It's going to be a new table for me. This is where I select a name for the program. Be careful about this name. The name should be a number, right? So let's call it 1005. Later you can change the name, but for this NC code, usually they are a number. And then you select the folder. I'm going to save it on my desktop, all right? So don't change the one at the top. This is where the program is sources. You just change the output folder and the name of your file, and don't forget the name of your file should be a number. Let's test if instead of this, if I select a name, let's say I call it project. Let's see what will happen if I say post. So see, it says, sorry, the name must be a number. Okay, so tell you. Whatever, doesn't matter. 392. So post. So this is a desktop. Save. You're done. Let's go to desktop and see what will happen. So it opened this file for me, but I can close it. I'll show you the actual one. Sorry, my desktop is busy. So this is the file, right? If I open it, and it's going to be a TXT file. So this is the file. Let's just quickly look at these. So at the top, there are some like the tools, the diameter of the tools, and like it says end meal. Those things we just ignore. The program is not care about that. Even we can delete those. Similar to when you do the coding, the one who has this semicolon there, it doesn't do anything for you. Then we have these G17, G71, M26. And then we come down, we have H0, then we have Z15, Z5, all right? What are those? All those G are standard, basically, codes, which for all the CNC machine in the world, they are the same. For example, G17 means going to the home. You tell the tool that, hey, wherever you are, go to your original place in the machine that you are, your original 00 point. G71 has another meaning, and we don't need to memorize them. You can, if I open my Google, in the past when I was a student, when we learned G code, we had to open books, but now you can just say G code, like a standard G code list or whatever. Just Google something and you see like this one. What are each of these? For example, G43 say something, G0 something. You see G code in even Wikipedia, list of G codes. They're all standard codes, and that's all. And you don't need to understand them. I just want to explain what is really G code. And at some point, it is just X, Y, Z. It's just the coordinates. You say, my first point is this X, this Y, this Z, right? And this is the I, J, K, and they're like the orientation of the tool. And then another X, Y, Z, and so on. You see, all these things, the tools has, like the program has created for us. Believe it or not, in the past, by the past, I mean, when I did my undergrad, if I tell you, you're just going to discover my age, right? But who cares? So 20 years ago, these codes, people have to write them by hand, basically. Like calculate X, Y, Z, and then enter them to the machine. Now programs create those for us. So this file, this is all we need to go to a CNC machine. We put it on our USB, we go to the CNC machine, we plug into the USB machine, and we hit run, and hopefully we get this part that we want. Last year, all the students, after they created their G code, they come to the lab and they plug in and they watch what happened. Unfortunately, this year, you just need to just submit the G code. But if you are around in future, if things back to normal, please feel free, bring your file to me, and then we will do the basically your G code together to see how it turns out. Because that was the fun part of basically the work, but now just need to rely on the simulation. One last things before we go, let me open a new file. Do you guys have a question so far?
Not really, but I'm just curious. Do you have any like old photos of the work from the students that made using the CNC?
I have the one that I created. I may go next week to the lab to create one, and I bring to show you. Did I take a photo? I guess I did.
No, I'm just wondering because I just want to I just want to know if there's any interesting designs from
yeah. So what I basically a student last year they did, and also you do for your project, is they create a pocket which was their name basically, and I will check if I guess I video some of those because there was some funny one when the chatter happens, they set up the feed speed very high and the quality was bad. But what I will do, I create two, one good, one bad, and next session I will show you. But let me quickly show you what the student last year did, and also you need to do. Again, one more time, we create a pocket. This one I'm not gonna explain to you, so it's just gonna take a few minutes because I realize that we are passing time. So this is the size of the things, done, extrude, thickness, done, right? So the pocket that you need to create is your name. So click on that one, okay, the surface. The previous example was just a simple one. So create, see here, open create, and you see this text here. Create text, click somewhere there, doesn't matter where, and then let me bring that table here. Type whatever you want. Let me type my name, Ahmad. So you want to rotate this one 180 degree, but you can have an oblique because some student they did, like last year it was oblique. It doesn't have to be horizontal. Make it bold and change the font, maybe 20. Oh, I have more room. Let's make it 30. Do I have room? Yeah, really, I have room. So the font. So last year I told the students create like a font that is machinable, something simple. Let's go with this Arial. This seems to be the simplest. But there were some funny one that last year I saw. So, and then click OK. And then you can, you need to just bring this corner and put it where you really want. Maybe the font 30 is too big because you see this corner is a little bit, but that's fine. This is just for show you. Okay, this is our name, and then stop sketch. Okay, so this is what we want to be the pocket. Click on extrude. So again, the extrude can be positive. If you like, you can do that machining. So it means now your pocket is totally different. But for this project, I prefer you guys to do a pocket. So the pocket means negative going down, 5 millimeters. Let's set it 5 millimeters. Okay. Now, this is exactly the same as what we had before, right? Except now you have to go through the pain of putting like all these fillets there, right? And after you remember for the design, this sharp corner is bad. So you need to do one by one, this fillet, this one. No, not the one on the top. Let's deselect it. This one, all these corners, right? This one.
We can ignore the bottom corners, like the bottom edges.
Yeah, you can ignore the bottom one because we do a flat milling, right? If you do a flat milling, the bottom can be straight. So as you can see, it's a lot of work. If your name is long, then that's okay. You can go with a nickname, a shorter version of your name. 2 millimeter if I go, no, too big. 1 millimeter, still too big.
Is it necessary to do your name?
For this project, you should, but no, you don't have to. You can do whatever you want, right? The diameter here, I can change the radius, but I don't want to make it looks too bad. Anyway, you do that one, all right? And then the rest is, you do for the rest, I'm not gonna do that now. You go to the manufacture part, the first step. So remember, you need to do 3 steps. Setting up, so new setup. We don't have any extra material. So you go to this yellow one, we say we don't want any extra process, 0 and 0. like it removes the material from it. Then the origin, we prefer to select a point, and that point we prefer to be this corner. Also, we like to go with X and Y. This is to be our X, Y, we flip Y. So now we have this one all set. We are happy, okay, this is our X, Y. Second step, you select 2D pocket and you set up all of these things that you need. You select your tool. Let's go to the tool. And let's go with that 3 millimeters that we have. The material I ask you is aluminum. Go with aluminum and you select the tool. Maybe this one is not the right one, but I just want to quickly show you. And then you go to the second part, which is selecting your pocket. The pocket, it's obviously like this one. You select this pocket and you click on control and you select the rest of pockets. But of course, it's going to give you error maybe because the pocket is basically the corner is not, like they are sharp, right? See, it does not really select it. So let's stick with just this letter A for now. Or let me try if you can force it to select M, A, and D. If it gives me an error, we realize it's because of that, basically that sharp corner for the other letters. So the rest will okay. Okay, what Ahmad you ask is the multiple step, right? This multiple step, this is the one here. So I select multiple steps rather than doing it one shot. Now this is where we can select. So instead of 0.5 millimeters, why not we do like 1 millimeter as a stepping down. And then we press OK. Okay. So let's see what happens. It gives us the toolpath. But you see, it's just for, it managed to get it done for letter A and H because M, it has this, like this narrow area here, which this tool that we picked is not going to pass this. So that's why it doesn't create a toolpath for us. The machine cannot do anything for us. I tested this one before. In the actual machine, the letter H you get, it's like a premature H. And why? Because you see this is narrow. So the tool we selected, the diameter is 3 millimeters, so it's not going to pass there. So you're going to play with that one to figure it out. But if you are happy with that part, you go on this portion, action, and you just check the simulation. You play the simulation at the bottom here, see how it looks like. See even the letter A, let me turn off these holders, so just show the shaft. Letter A is not even going to create a nice letter A for us. So let me turn off the toolpath here. So this is what you will get. You see? And problem is the tool that I selected is the diameter is too big for this font that I selected. Is it clear, guys, now? You got the idea?
Yes.
All right. So enjoy. Go and write down different things. Maybe if your name is long, that's fine. Just write your initial A, B, C, or whatever you like. And then after you finish with that part, you know the last part. You go to action, you post-process, you select a number like 7 and post. On desktop, save. When you see this window pops up, it means you created the G code and your file is there. That's the file. No, 107. And you just submit this one on Canvas for me, but rename it. Now you can rename it Ahmad CNC. Ahmad CNC Pocket. You submit this one. Okay. And if you open this one, it's a TXT file, you see all this G code. All right, guys, have a nice evening.